For the final challenge, we had to develop a speed control for a DC motor using a PID control system. We used an external computer. We used two nodes, and a third node was developed in the microcontroller to run the motor.
The first step was to connect the hardware and regulate the addresses and the PWM with a code. To obtain a mathematical model, we made an open loop to see the response of the system with an input of PWM. As we see, the open loop is not enough to optimally control.
In order to solve the challenge, different codes were made. In total, there are 3 codes: a program to be able to generate signals like sinusoidal, quadratic, or step. The signal will be generated with a respective of time, and they will publish in a topic called setpoint. Another program that will serve to function as a PID will subscribe to the two topics: setpoint and motor output. The objective of this program is to send the signal to the motor and feedback with the signal with the motor that the motor sent us. The signal that will be sent to the motor will be the topic of motor output. The last program will be for the microcontroller. It will subscribe to motor input to get the signal, and the motor will work. The motor will send the encoder pulses to the topic of motor output.
Develop an open loop helps us to know the system that we want to control, because if we don't know how it works, the closed loop can be deficient.
Well, from all the 5 weeks, this was the most difficult challenge. And well, for me, the difficult part was to obtain the gain of the system control. This was a method of trial and error, but at the end we obtained the values we wanted. Thank you.
The challenge was difficult, but not impossible. One of the most difficult parts was the frequency in which the topics were publishing, because if these are not in the right frequency, there's no optimal communication between the computer and the Arduino, resulting in possible damage for components as the DC motor.